Hi Coach L, this is the tutorial for reading a photoresistor. Let's go. This is the basic code for reading a photoresistor. So it can use detect darkness and turn the LED on, and when it's not dark it will turn it off. So we're going to first define constants for the pins that we're using. So sensor pin equals 0 and LED pin equals 9. Then we're going to set up some global variables for the light levels so the light calibration for this one, and then the raw light value. Then we're going to set the pin mode as an output, the LED pin as an output using pin mode here. And then we're also going to use light cal equals analog read sensor pin to take a single reading from the light sensor and store it as the light cal variable. So that's going to give us the preliminary value to compare against the loop. So it's just the base amount of light in the room. Then we're going to void loop. And so we're going to take a reading using the analog read function of the sensor pin and store that as the light value. And so then we'll use the if statement to define that if the light value is less than the light cal minus 50, then the digital 9, so it's going to turn the LED pin on high, so turning it on. And if it's not less than light cal minus 50, else digital 9 low, so the LED will turn off. And then that's it. This is the basic board for reading a photoresistor. So here we have the LED. The cathode is connected to the ground through this wire and then onto this wire, which is connected to the ground over here. And the anode is connected through the 100 ohm resistor into this orange wire, which connects it to the number 9 pin for the voltage. Then we go to the photoresistor here. Through the 10K ohm resistor, it is connected through this black wire to ground through the same black wire here to this ground. And then the yellow wire is connecting the photoresistor to the analog 0 pin. And then this orange wire is connecting the photoresistor to the 3.3 volts by connecting to this red wire here through the orange wire into the 3.3 volts. That's it. Oh, and sorry, it works if you cover the light on the resistor. This is the modified code for reading photoresistor. We're going to use the photoresistor to turn on more LEDs for the less light available. First, we're going to create constants for our pins. So the pin for LED 1 is 9, pin for LED 2 is 8, and pin for LED 3 is 7, and the sensor pin is at 0. We're going to create global variables for the light level, for the calibration value, and the raw light value. Then we're going to board setup, and we're going to set all our pins as outputs, and then use the analog read function to take a single reading from the light sensor and store it as the light cal variable, and that will give us the base light value of the room. Then we're going to do serial begin to start off our serial monitor. Then we're going to void loop. We're going to take reading using the analog read on the sensor pin to store as the light value. And then using our if and else if statements here, we're going to turn on different lights. So first one here is if light value is less than light calorie minus 150. So this is the most sensitive to changes in light, and will be the last light to turn on when the light is decreasing. And that will turn on pin 9, and then serial print along with print 9, pins 9, 8, 7 will be on. Else if light value is less than the light calorie minus 100, light cal minus 100, this means this is like the medium sensitive to change in light, so it will be the second, pin 8 will be the second to turn on when the light is decreasing, and serial print ln will print 8 and 7 on. Then else if light value is less than light cal minus 50, so this means this is the least sensitive to change in light, and therefore LED 7 will be the first to turn on, and then serial print will turn on 7 is on, and then else, so if it is bright out with no change in light, then it will turn all the pins on low, so turning it off, and serial print will print off. And we'll see serial print here, so it's off. We'll go 7, 8, 9, all on. That's it. This is the Arduino board for reading a photoresistor modified. So here we have LED number 1 with a 100 ohm resistor, and this is the wire that is grounding it, connecting it to this strip here. It is wired by this longer wire to the ground over here. It is connected to pin number 9 through this orange wire right here. It goes through here and into pin number 9. And then we go to the yellow LED, 100 ohm resistor again. It's grounded through this wire here, again to that strip. And then 100 ohm resistor connects it to this yellow wire here, which connects it to the pin number 8. And then the blue LED here has a 100 ohm resistor as well, and the ground is connected through this wire here to the strip again, and this yellow wire that is connected to pin number 7. For all the LEDs, the cathode is the ground, and the anode is the voltage that goes through the colored wires. Then we go to the photoresistor, and again it has the yellow wire to the analog pin over here, and the orange wire is connecting it through this power strip to the red wire to 3.3 volts, and then it is grounded also through there's a 10K ohm resistor, and it is grounded to the blue power strip again, and it's grounded through this ground. And so we'll see as the light decreases, more LEDs will turn on. Here we go. More light this way. So all done.